This time, I will talk about power comparison. The power comparison offers you three main functions. Since module comparison and program comparison are almost identical, I will only talk about module comparison. When performance analysis shows that a particular module has become slower, we could analyze the SQLs performed by the module and find out which ones take longer to execute. But we also need to do a comparison with past performance history and find out which SQL has become slower. Power comparison is quite useful for this purpose. For example, let's assume that elapsed time has become longer for the other related module. Select dates to compare. The results lets you easily identify the causes of the module's degraded performance. Showing on the left is elapsed time. You can see that wait time in section 1 has become significantly longer. You can also see the execution count was very high. Let's now do a detailed analysis to find out why there were changes in elapsed time. The elapsed time gap analysis section lets you compare the SQLs. The first SQL's elapsed time has a difference of over 270,000 seconds, and the second SQL's elapsed time has a difference of over 190,000 seconds. By clicking an SQL, you can easily see the reason of the degraded performance. The right side of the screen shows that the SQL's execution count has actually increased. And the average elapsed time has not changed significantly. The second SQL has also increased in execution count, but its average elapsed time has actually decreased. Based on these results, the elapsed time suddenly increased in section 1 for the new order module, not because the elapsed time of each SQL increased, but because the execution count increased. For the second example, let's change the search conditions. We will set section 1 to January 19th and section 2 to January 20th. The results show that elapsed time has a difference of over 2 million seconds. But there is no significant difference in execution count. Elapsed time of the first SQL has a difference of over 500,000 seconds. When you look at the SQL, you can see that each execution became 1 second slower. And the reason of the delay can be deduced based on the wait events at the bottom. Performance became slower because waiting became longer for waiting events such as write complete wait, free buffer wait, and DB file sequential read. This tells us that there were I/O-related conflicts in the section. The peak time comparison, on the other hand, lets you compare peak sections with the previous day, 3 days earlier, or the same day of the week. For example, let's assume that a peak occurred between 9 o'clock and 10 o'clock on January 23rd, and compare the data to the date before. The results show that the total weight on January 22nd is lower than the total weight on January 23rd. You can see here that the total weight on January 23rd is at least 200,000 seconds longer. Particularly, you can see that the wait time of the first SQL had a difference of at least 60,000 seconds. The average wait time also has a difference of about 0.2 seconds. You can right-click to view the full SQL text. This shows that the insert statement became generally slower. By clicking the 10-minute bar, you can view the SQLs with greater wait time increases in the 10-minute section. Also, by clicking the Active User Session tab, you can do an analysis based on active session. That's all for the power comparison.